Okay, welcome back everyone. Sorry about Friday stream, I couldn't really make it. I think I overdosed on coffee. And yeah, this is how it ends. But I am back today. And of course I was a little bit busy over the weekend and I was supposed to do just a tiny little bit of change, and I ended up redoing half of the keyboard. Let me quickly show you what's new now. So I decided to move this key lower. This way I can have a 1.5 length switch over here. So basically the same length as this one. This one can be also 1.5, but usually I do 2U, which is kind of like nice. I like how it looks like. So that is one change. And I also decided that we're not gonna mess with all those different heights for different key type. So MX and Chalk, everything is flat now. I think that wasn't a good idea, only makes things more complicated. And I realized that in the end it shouldn't really matter that much because you're gonna have a tenting kit, something like over here. So this is the way how I tent the keyboard, and this technically makes it better to use like that. We don't have to worry about different key heights because like by default this will make like the thumb the highest and so forth. So it's very nice like that, very cool. So I think it makes the whole keyboard easier to design, to assemble. No need to worry about anything. And I think that will be it in terms of like any major changes. Let me take a look. I was also looking at the bottom plates. Yeah, so Chalk and MX both the same right now. I think it's gonna be okay. I don't think I'll be changing that in the future. What have I done else? Not much, I suppose. Okay, from the bottom we had most of the things settled. I managed to check the diodes, they look okay. What else do we have? What else? In terms of extensions, have I done anything over here? Yeah, I think that's all that we had last time. See, there are still some old designs, I suppose. Yeah, but like mostly done. So partially we'll be finishing this today. But before we jump into it, let me show you something. So I have some of the parts print already, even the most recent ones. I think the diode I showed you last time. So the fit is perfect. That's very good. Sits right at the bottom. So that's thing that we don't have to worry about. Okay, so this is how it looks like with 1.5U over here. I did it because I noticed that it's a little bit, the keycap, it was like a normal keycap over here, it was a little bit too short for the thumb. So I decided to move it down, there's enough space. And also for this one I decided to go with 1.5 as well, because before it was just 1U, and it was it's up to you, I would say, if you like it or not. I think for my preference I would stick to this one. This can be 1.5, 125 or 1U. All of them should fit. This one is 1.5, so basically anything that is 1.5 and less should fit as well. We have a encoder over here. This one also fits okay. And I did it because if you look from the top, so usually the keyboard is used at an angle. So I like having a little bit more of surface under my pinky right here whenever I press it. Not like it was not enough, but yeah, I think it's okay. And as I said, it's up to whoever will be building it, can use any kind of key. Yeah, other than that, not much changes, I'm afraid. I managed to check these as well, so I have different extensions print out. The one for trackball and for the circuit trackpad and so forth. This one we don't have to worry about too much. Actually, I already checked for the circuit. The height was okay. Also for this one, the height is kind of okay. If I don't like it in the end, this can be always changed. So I'm gonna leave it at that. This height is quite okay. If you look at the profile, I think it's okay. Like, it's not that clunky anymore. And I also decided to keep the trackpad, not the trackpad, sorry, this is the encoder. I decided to keep it like very low so it's aligned with other keys and it's not getting in the way of this one. So yeah, should be good, because like even when you're using it, usually if you rotate, it will be a little bit to the back, I mean to the front of the keyboard. So it's not like we're gonna hit this one. If we do, we can always change it. This can be lift up. We can also change this part. It's not a problem. So this one fits nice as well. I also have 65, which also looks kind of nice. I can't wait to have it like on the board. Yeah, even if I don't like it, how high it is, how far it is from the bottom of the keyboard, this can be changed anytime. That's perfectly fine. We can also change for everything else. So yeah, not an issue. Although this one looks kind of like the surface of the trackpad seems to be a little bit like too long. Like if you want to reach it, I'm very curious how it's gonna look like once like in use. Yeah, but as I said, we have plenty of flexibility. We can change almost anything. The core part, which is this one, has everything already embedded in it. So we have diodes, we have resistors, almost everything. The only thing that will be separate will be MCU over here, and that's pretty much it. So yeah, it's looking good. Today we have to take a look at the remaining extensions, what we have there, and we have to like I think most of them is done already. We still have to take a look at the tenting solution, which is also partially done. It's kind of easy to do. And today I would also like to revive my old Chordie, or maybe not so old, the one that was mutilated when I was trying to figure out what was wrong with I2C. So this one has been stripped from the resistors, and I think, yeah, I would like to bring back trackball over here. I have the top already. So maybe I should even start with that, because technically it should be easy, just 5 minutes. And we should get it attached if I only have a trackball sensor anywhere. Ah yes, found one. My own design. So yeah, maybe we should give it a shot. Try to attach over here. I don't really know what are all those wires over here. Okay, I think this one should be clock. Or maybe not. Wait. Ah, yeah, right. So yeah, so this one, I think this one was prepared for this, and it didn't work, so I stripped it. Yeah, so I guess what I can do just to bring back the wires, okay, we have VCC, I'm gonna keep this one. I think we have ground over here, so one should be I2C, one should be SDA, so these are like from I2C bus. I'm gonna have to solder new wires over here, but on top of that, this bottom piece, the bottom part, is like the new design, if I can call it, because previously I had it done, the mounting screws would go onto the main part of the keyboard. Actually, that was the old main part. Okay, now I realize that we have the flexibility. We can choose how we want to have it done. If you want to have these on top attached to the extension part, or if you want it from the bottom. Okay, something we can take a look later, but first I'm gonna solder this in, we're gonna flash it, and I hope it's gonna work. Makes me wonder if there is any pull up on I2C, because I have removed most of the stuff. Let's fire up our meter. Okay, what do we want to check? Okay, we want to check what's the resistance. So from here to VCC, what do we have? 0? Okay. Okay, looks like there is no connection at all, which is not good. Makes me wonder, how about this one? Well, I think I removed all of them, so there will be no pull up on I2C. I removed from here and from both sides, basically. Yes, exactly. Okay, I have 10k resistors. I think I'm gonna solder over here. I wonder if I can stretch it from here all the way to the bottom. Okay, physically it should reach, but the issue is okay, not so bad. I'm gonna cheese it a little bit and just solder it like this. Maybe I should move it over here. Damn it, I cut it too short. I was supposed to reach all the way to VCC. Okay, so one is done. This one is clock. Over here there's data, so I hope I can reach. I should be okay. and it won't reach. Besides, there's also an issue. We have to make it somehow over the clock. How about we... It's such an inconvenient place. Okay, I think I will just add a wire to this one, and that should solve the problem. When I think about it right now, I think it would have been better to add these on the master side. Oh, well, I guess I'm not gonna add two more. So I just have to remember that in case I have any issues with I2C, then I should connect both halves. Would be nice to keep it someplace safe, for example maybe here, so it's not like bouncing around over here. Although if I solder it like tight, it should be okay as well, hopefully. Okay, I think more or less it should be okay. As long as it works, right? Okay, I'm not gonna put the bottom yet, just in case it doesn't work. Let's do the sensor on this side. Okay, so for this one I'm gonna be needing how many wires? I have ground and VCC already, so I'll be needing 4 more, right? Chip select, master in, master out, and clock. Okay, so 4. I like doing it this way. Clock is usually green. Master in, slave out, usually yellow. Then master out, slave in is orange. And the chip select I usually pick white. So this way I tend to remember what is what. Oh, this one is really messed up. Maybe I'll be able to clean it a little bit. Okay, much better. At least I can read what is what. Hey man, hey, Tech Teams 384. Welcome, welcome. How's your day going? Okay, now I have a difficult task to hit this one. How's the... I have to fit this, which is chip select, over there, just between the standoff, and yeah, it's gonna be difficult. Are you building keyboards as well? Oh, kind of. What is it that you're building? I am very curious. Oh yeah, cool, macro pad. I also have a macro pad waiting. I was hoping maybe I can start today, but we still need to do some things for this one. I still have to finish this, then we have to do some CAD to finish the project, and then if time permits I would like to start a macro pad, and we'll have a build coming up as well for Chordie. It's gonna take a while. What kind of macro pad? How many keys? What other stuff you want to have on it? Sounds interesting already. Oh, 9 keys, yeah. So I assume it's gonna be 3 by 3 or some other layout, like non-standard. Scroll wheel. How are you planning to do the scroll wheel? Because you have a lot of options. Oh, 5600. Yeah, we did it on the channel as well some time ago. It works, kind of nice. But I think better one is MT6701. I think because it has a higher resolution, I think it's 16-bit or something like that, and AS is 12. I'm just like shooting right now. I mean, both work okay, but my personal favorite is 6701. Which firmware are you planning to use? QMK maybe, or you want to go with something easier like KMK, or maybe wireless? Then I guess your best option would be what's the name of the wireless? ZMK. I think for mine I would like to go with ZMK this time around because I would like it to be wireless. Although you can have wireless with QMK as well. Yeah, I agree. Not much difference, that is true. But I wasn't aware there is so much difference in price between them. My impression was that they are both roughly the same price. Oh wow, cool, custom hardware. Do you have the skill? What language? Rust maybe? Oh, JS? So there is like a JS that you can run on the microchip? Oh, that's so cool. I know there is a Lisp that you can flash onto different CPUs and it works as well, but I didn't know there is a JS. Oh, that's cool. Soldering, but you're gonna be soldering everything, or you have like a already done board with the chip? And you just need to solder the wires and that's it. Oh, okay, solder the wires. Yeah, sure, I have few tips. Do you have any equipment already, like a soldering iron or anything like that? You have any tools already, or want like a general advice, like what tools to buy as well? So oh, you have a PCB as well. Oh, that's kind of nice. Well, so I don't know if I have any tips to share with you. So sounds like you know your stuff. So I don't think there's much I can help you with. So you're gonna be doing PCB, not even hand wire. This one currently, it's this keyboard. So this one is previous prototype. This one is fully functioning. And yeah, it's like a chording keyboard, so you don't have to move your hands at all. You can type like this, just press. And I have a trackball. So yeah, so that was the main idea behind it. Have something small that you don't have to move your hands too much. Yeah. Okay, see you in 10. Oh yeah, hot swaps. Yeah, you can do hot swaps. It's a good choice actually, because then you can play with your different switches, right? So you can choose. I would recommend doing like a one PCB for both for the Choc and MX, because you can have two hot swaps sockets on one PCB. They fit okay. I think I should I have a project somewhere, but most probably I don't have one in KiCad, and the question is, do I have anything on... that wasn't GLC, what was the name? Easy EDA. Of course they logged me out, holy shit. I hate this, I hate this web page. Why would they log you out? Yeah, forget it. Okay, yeah, so I can't really share much. But you can have two sockets for one switch, and they fit next to each other. The only issue with it is that you can't have a board that you can do both sides, like left and right on one board, because then the holes don't align. But maybe someone figured it out. I don't know. I haven't really done much research around it. Usually if I do hot swaps, I will have left and right side on different PCBs. And if you go with just one, I think we did that on the stream for Chordie. We have a PCB as well, but there I wasn't even using hot swaps, so I was able to do left and right side on one PCB. I think I even have it somewhere. And that was pretty nice project, I have to admit. It turned out quite okay. Let me see. Yes. But I had it a little bit different because, as you can see, I wasn't even using any standard cutout for MX or for Chalk because I was soldering wires anyway. But there will be new PCB, and this one will have proper switches and everything. So yeah, if you can stick around in future episodes, I will be working on it, and I will be doing most probably I'll be doing left and right, and with two different sockets for each switch. So then you will be able to switch between like MX and Chalk, and it's very nice. The only thing that you have to take care of is that you need to have two different top plates, because for MX you need a thicker plate, and for Chalk you need 2.2. So then you have to do two different top plates, but that's the only thing that you have to worry about. Yes, I am using both. Over here you have Chalk. This is V1 version, so these are low profile. And over here it's the same keyboard basically, but this one has MX keys. This one is a little bit fancy because the switch, the housing is Otemu pitch silent. But I swapped the springs, so inside I think I have 25 or 20 grams springs. But I think my future build I will just use normal springs, maybe like 35 or something like that, because the 21s are very difficult to get. And I assume if anyone will be building it in the future, most probably not being able to source the springs is gonna be a huge problem. So I would like to take a look how does this keyboard work with normal switches, not like super light. Oh, injection molding is it's a different story. I think it starts like 10,000 USD, if not more, for like a one-offs like this. I think the only way to go is FDM, so 3D printing, which I highly recommend. If you don't have a 3D printer and you want to do keyboards, I think 3D printer is like a must-have. If you want to design a lot, if you want to do just one, then maybe you will be able with just like third-party service. But then it's difficult to prototype because usually nothing really fits at the first try. If you have access, yeah. If you have access, then perfect. Should work perfect. Okay, so the sensor is in. Looks like the wires are holding. So far so good. Let's flash it and see if it explodes, and if not, if anything even works on it. Yeah, I guess I will be needing this right now. Okay, I hope the flash will work, because I can flash it by holding this and plugging in the power, but I need to do something. Okay, let's go to our security page, so just in case something happens, it goes high wire, it won't kill the stream. Did you try to make your keys wireless? I haven't tried that yet. I don't have too many MCUs that are wireless. I think I bought just one, and I don't even know if QMK can support it or ZMK. I haven't tried that, but yeah, I do have plans. The good thing about my keyboards is that I am using I2C expanders. So basically you can just take out the MCU and you can put in any other MCU and just flash it, as long as there is a firmware for it. So it's not a big deal to make my keyboard wireless. Yeah, the only issue might be trying to fit in the battery somewhere. That's a different story. Okay, I think we need to change some settings on firmware. Let's take a look. That should be easy, because I just need to change few defines. Dumbass. Okay, was it here? I think it was over here somewhere. Right, so we don't have that on this keyboard, but we have this one. We have EC11, we have MCP, and we're gonna have a trackball, and it's 2040. Okay, send. Right, perfect. Oh, I have to say that I never tried ESP32. I know these are quite popular, and I know they have really good wireless. Maybe I should take a look. Okay, no errors. No errors, cannot be. All right. Okay. Looks like it's up for flashing. Okay, let's see what happens now if I press anything. Okay, the keyboard works. How about this one? Okay, looks like, yeah, looks like it works as well. Okay. Okay, perfect. What a surprise. So I assume I can put everything back together. Okay, let's start with this one. But this repo with BLE and keyboard and mice, does it have any other features like QMK that, for example, you have layers and some other stuff, combos? Because like QMK has a lot of different features. I guess I'm good with 2 screws, right? We don't need more. Maybe one more over here. Okay. C3 Super Mini. Okay, I need to remember that. No, I have not explored this part yet. But I can tell from Reddit a lot of people prefer wireless. I don't, sadly. I'm more of a wire guy. Okay, welcome back, Jidin Burdan. Is this correct? Alright. Okay, this fella is done. Oh boy, this one is terrible. How can I put it into one piece? Okay. I've been to Turkey, beautiful country. Okay, so just like a basic keyboard, something similar to you have similar stuff for like AVR and ARM in Arduino Studio, right? There's this like a library that can send keys. Okay, sounds okay, but like I still would need at least like layers and some other stuff. Oh, you can make layers. Okay, so that's something more than I think standard Arduino Studio library, because I don't think that one has any layers to. Okay. Okay. So something worth exploring. Well, I just started an hour ago. At least one more hour, maybe more. We'll see how it goes. I really would like to start this macropad today. At least have a like the basic layout maybe. I can decide if I want to have 4 keys or if you want to have more. Yeah, sure, ask if I can help. Circle thing? What is circle thing? Jitin Burdan, I don't quite understand what do you mean by circle thing. You mean this? Because this one is a sensor for the trackball. Okay, so this is like a standard mouse sensor. I don't know if you can see on the close-up, it looks like this. So I'm gonna put this, and it's gonna be a trackball. Something like, it's gonna be like this one. It's the same, basically. It's also a trackball. Question? Which question? Okay, the wired mouse. I don't see a question anywhere. Ah, what is weird? Ah, damn it. On the mouse, I mean, if you want to do it for cat, I think the trackball would be the best. Something like, I think it's called Space Mouse or something like that. Let me take a look. There is this very popular thing, Space Mouse. Yeah, something like this. I have no idea how it works, but this is very popular. But this is not quite a trackball. I think this is more or less something like a... Okay, how can I get there? Oh yeah, something like this. But I think this part over here, this is not a trackball. I think this is more of a encoder, like you can do left and right, but I don't know, I never used that. It looks like they have quite a lot of different options over here. I know this is very popular in like cat people, and it looks kind of ergonomic as well. But like having a trackpad, I mean, having a macro pad with a mouse, that might be a little bit weird indeed, because you need to have like a good support for your hand if you want to do like scrolling. Are you going to do the trackball and it's gonna be done, or is there more parts to integrate? Okay, so so the mouse thing is something different, right? So like a trackpad, what? Yeah. So what? I have a trackpad over here, and I think this one is the biggest trackpad you can get on the market. This is TPS 65, and I think it's diagonally. I think it's 65 centimeters. So as far as I know, this one is the biggest. So, but you can't really have like two fingers on it, like, you know, like that. So usually you will go like this. You will move the mouse with this finger. And then, for example, if you want to do something, you can zoom in, zoom out. If you want to scroll, you use two fingers, left and right, this kind of stuff. Yeah, but for making trackpads, you're gonna be needing a chip like this. And they have some requirements. I'm not quite sure if you can use a flexible PCB. Maybe you can. I never digged into it. But they also have like a maximum number of rows and columns. So you can't really go like bigger than the spec because it will be not accurate then. Yeah, but that sounds very ambitious to do the trackpad from scratch. Okay, looks like I got it in. Oh yes, that's true. Apple Magic Mouse and Magic Trackpad is actually even bigger than that. But I have no idea what kind of chip they are using and if you will be able to make your own trackpad the same way. Or you can always use the Magic Trackpad and just build something around it, just add some keys. Well, with this one, next thing I will focus on will be checking the extensions for Chordie, and then I need to do tenting. And after that, we'll see how it goes, how much time. Maybe we can just do the trackpad, at least like the basic outline. There you go. It's finished. Damn. Okay, let's see if I can swap it with this one. Okay, does it work? Yeah, it works great. Cool. nice. What was the PCB? I am using usually pre-made stuff. It's gonna be either RP2040. We just did extension that can fit this one in. And some time ago I've been using AVR, so this is like a Pro Micro. And now I'm also using RP2040 Pro Micro, which is this one over here. This one is from SparkFun, kind of expensive. So Raspberry Pico, it's this one that I've been talking about. You can buy it almost anywhere and it's kind of cheap. They even have wireless, but I don't know if you can use QMK, for example, wireless with it. And the SparkFun, what was SparkFun RP2040? Okay, $11 over here. Not bad actually. Oh, ZMK works? Oh, good to know. Good to know. Because I was also planning to jump into wireless, but I haven't really looked into it at all. I know I have to find a battery that will work. I think the best would be to have a 3.3, there's like a small flat round battery, but then you really have to put a lot of work into the keyboard for it to be really low power. Okay, where were we? So this one is done over here and it works. Very happy about it. So for this one I need to check, first thing I need to check the extensions, but I think I went through it already. So this is the common part, and if I would like to go with this encoder, I think everything was settled already. I think we went with this one. Yes. So this one is done. Well, I think the main thing that you have to do would be to just go with some kind of a, how it's called, like an interrupt. So for example, if I have a I2C extender or expander, I can have there is like an interrupt output which will go high if one of the inputs is changed or anything like that. So then you can have the main CPU just sleep all the time, and it can be woken up by this interrupt, and then it will just read whatever is there on the expander and just process it and go to sleep. So I guess that's the key to low power keyboard, but this is just my assumption. Okay, so this one is done. What else do we have? Okay, we have magnetic ones as well. So the mount is standard like for everything else. And what do we have? Okay, that's the knob. Okay, the question is, do I have the bottom plate done already as well? I think I have. Let's hide this one. Okay, that's the common part. Okay, so it's looking good. The holders, okay, this part is done. And this one is done as well. Okay, I think I did that over the weekend. Okay, and then we have this one. This one was for the mouse encoder, which I really liked. But I think there might be something missing over here. Ah, yes. Okay, so the knob is the same. Okay, so nothing is missing. So that's the knob. It's the standard one, and over here we have a holder for the mouse encoder. Okay, so this one is done as well. Okay, what else? What else? Okay, magnetic mouse. Okay, TPS. So this one will be a little bit different. So that's not common part. Okay, so the bottom is done. I think we did it on the stream. Okay, something like this should be good. And that's the left side, so there will be no diodes over here. I can drop it right like this. Okay, so 43. How about 65? Okay, this one is done as well. Cool. Well, I am now checking what stuff I need to do to finish the project. So this is a CAD for this keyboard that I am using right now. So there have been some changes recently. So what I'm checking now is what is left to fix. I have these extensions already. So these were fixed already on the previous stream. Yeah, and the whole keyboard looks like this. I can just add switches, right? Yeah, so the main idea is to have the main part, which is this. So I can put everything inside. Like I have some resistors over here. Expander will be here, mini jack and so forth. And then I can add like different extensions, whatever I need. If I need a like a scroll or something, a volume controller, or if I need a trackball. So I can just add different extensions, and like some of them will house the MCU as well. So all of this looks like it's done. Well, I have no experience with Fusion 360, but I think it's quite good. I've been using this, which is Design Spark Mechanical, for many years now, and I think it's okay. It's way cheaper than Fusion. I think it's very similar in how you use it, and yeah. From Singapore. I have a lot of guys from India watching. You're asking about university? No, no, I'm an expat. Alright, so this is done. So let's take a look how can we do tenting, which shouldn't be really difficult at all. Let's make a new component, let's call it tenting. Yeah, for Turkey, like what time is it? I think it's kind of early. Oh, maybe no, it's more like noon. Yeah, so noon, my lucky guess. Okay, so how do we go about the tenting part? Okay, so that will be, okay, this one. Okay, that's the one where we will have a trackball. And this one will be the most difficult part because I wanted it to be lower. Already educating, thank you, thank you. I'm happy that you're enjoying it. Okay, see you in the next stream, probably tomorrow or Wednesday, depending on the schedule. You can check on YouTube, there will be upcoming. Oh, hello there, my biggest fan. How have you been doing? Okay, how to... Okay, let's do it... Thanks for subbing, Jindi Burdan. See you. Yeah, I've been doing okay. Oh, cool. I thought you were leaving. Okay, I forgot I changed this part. Because I moved one key. I'm trying to do the shape of the bottom, that how it will be tinted. It's gonna be something like this. So then you can have the keyboard at an angle. So now I'm trying to do the inner outline, and then we can just do the outer. Okay, thank you. See you around. Okay, one sec. And I'm back. Okay, looks like we don't really need this part to be the stick over here. Maybe I can just go from here. Let's see. If I do 10, oh, that's too much. Well, maybe because I moved it a little bit, maybe we can do it a little bit different. Because it doesn't have to be this thick, although, okay, it has to be at least 8 millimeters to fit the rubber. Because we have these stickers over here and the rubber fit. What is the size? I think they are 8 millimeters. Okay, 766. You can do 8. Okay, I'll be right back. Expecting delivery. Okay, I think I will do it like this. So I will have a thinner like an edge. So this one is 8 millimeters from the edge. And then whenever I have a screw, I will just make like a circle like this. I mean, over here we don't really need it because it's like within this part, but over here it's like half. So maybe only those parts where there is not enough space, or like here. Okay, so now I have the inner wall. All I need to do is just follow the outer wall, and that should give me like a proper shape, proper body, if I don't mess up anything. Okay, let's see. Okay, I think I missed something. Oh no, not quite. Looks like it's fully enclosed. Okay, looks like it's one shape. Okay, I think I know what's the problem. Maybe this one? Nope. Okay, we can do it different way. I can always feel the shape. Okay, like this. All I need to do is to have an opening over here. Perfect. Okay, so this is like the base tenting for the main part of the keyboard, but we still have to do additional parts. So maybe, okay, I think I'm gonna... Okay, first maybe I should move it over here. Let's make a copy of this one. Okay, I'm gonna leave it over here, and let's take a look if we would like to have, for example, okay, let's bring back the base and the bottom, for example, this one. Okay, so okay, how can we do it? So maybe it would make sense if I have this part like this, and then maybe for different extensions there'll be like a different different tenting. Let's take a look. Let's say, okay, how about we call this one common, because this one will be for all of them. Okay, let's see, what do we have first? Okay, so that's the encoders. Okay, I guess for all of them, the overall shape is the same. There's only difference over here, how they're mounted, but this one doesn't bother me at all. So it should be easy to do. Okay, let's jump into it like this. Okay, let's do the outer first, like this. Okay, and now let's see if I do 8 millimeters. Okay, looks like it's enough. Over here we don't need to do like on the inside. There's no need to do tenting. The outer will keep it. Okay, so basically I don't need this one as well, right? Only this part. Like this, and okay. While we have the circle, I can do this as well. Okay, now I have a nice cut. Okay, that should do it. Okay, something is off over here. Such a tiny bit sticking out, but I think this is 8, right? 8 millimeters, okay. And over here, perfect. Okay, so I guess that should be it. I think I missed over here as well. Okay, I have more holes to open. Okay, and still didn't close. I think I forgot this one. Okay, I can't feel it. And I can't make it like... okay, that is very odd. Oh, okay. I think we have our issue. Let's take a look. Okay, still won't connect. Oh, finally. Perfect. Let's take care of those screws over here. Okay, let's take a look at this ESP, because I'm curious at the same time. Okay. Yeah, these ESPs are like crazy how much stuff they manage to fit inside. A Bluetooth, Wi-Fi, holy shit. Yeah, you have to set it on a PCB, right? Okay, so we have one part done. So that will be this kind of a shape, will be for encoders. So I can switch it on and off. So this part is common for like everything, because this one goes on the main board. And then we'll have this part. For the USB-C, I would recommend having these. These are like magnetic cables, very handy. And this way you will never damage your MCU, because it's very easy to rip off the socket, a USB-C socket from the board. So with this you will be safe. Okay, so encoder is done. Okay, TPS. Oh, for this one it will be maybe not so bad. Let's see. Okay, let's take the smaller one first. Cut this one. And where are we? Tenting, right. Okay, maybe I will do it like this. Let's do it maybe instead of like common. I mean, I will just do separate bodies, like not keep them in the same folder. Okay, so let's start with the outer wall. Well, I don't know. It's 6 already. Probably around maybe 7. Hard to tell. I would like to finish this one today. Seems like I won't be able to push the macro pad today. But I would like to finish this part at least. Come on, don't worry about me. Most of the time I am alone here, so it's fine. Go ahead with your stuff. Drop by on the next stream. Yeah, sure. Nothing to be worried about. Well, that's very kind of you. Okay, this one seems like it's going better than magnetic encoders. Let's take a look if we do it like this. Okay. Sure, no worries. I'll see you next time. Enjoy your day. Okay, what did I mess up this time? Why didn't it close? Okay, I think I know. So no screws maybe? Still no help. Okay, but managed to fill, so I'm good. So now I can do the screws. Okay, this one we won't be needing. Okay, I think it looks okay. I'm not quite happy with the distance over here, but I guess we have to live with it. Okay, so that's one, and we still have 65 to go. I mean TPS 65, not 65. More elements to do. Okay, let's do it. Okay, that's gonna be TPS 65. Yeah, sure. Come on, don't worry. Go ahead. I'll see you around on the next stream. And the same story here. I'll just do it like this. The outer wall. I hope it's gonna print okay. Let's take a look. One more thing. Okay, I don't have the bottom part done yet, but I have this one. So this one, there's like a hole. It's quite okay, but yeah, maybe I should revisit the bottom. Well, I don't think I have to worry about this part, that it's kind of like on top on this, because this one is used to lock the MCU on the other side, but no MCU is this short, so yeah, that should be okay. Okay, how am I doing now? Okay, that shit, and still didn't really connect. What is that? Okay, have I forgot maybe this? Doesn't look like I'm missing anything over here. Okay, now it's done. Okay, so one more thing, the screws, right? Let's do that quickly. Okay, this looks good to me. Yeah, so we have the common part over here, and we can just swap it with whatever we need. Small TPS, large TPS. We can do for the encoders as well. So what is left is pointing devices, right? So I think I can go with this one. Okay, so tenting, that's not quite what it is over here. A bit of a mess up. Okay, so we have pointing over here, so let's do trackball. Okay, do I have the bottom done for the trackball? I should have it somewhere as well. Okay, it's over here. Perfect. Okay, I hope I have all the lines done, and this time around it will close properly. Have I missed something again? Doesn't seem like it. Damn it. What is wrong with this stuff? Okay, finally. Sometimes you have to do some magic to get it to work. Which is kind of odd because that was a simple shape. I don't know why wouldn't it like fully fill it, but whatever. Managed to get around it anyway. Well, it didn't want to feel I had like an open shape. It was only, I could only see the edges, and there was this green thing was missing. I could only see the edges, and it should after I'm done in the sketch and I go back to 3D, every enclosed shape like this, it should be automatically filled, so I have a surface like this, which I didn't have. Yeah, but what I did, I just add two lines, one here, and then it managed to enclose this, and this one I just did by hand. It was okay. Most probably I'm missing something when I'm doing it. Alright, so I think this will be okay. So with the tenting solution, there's not much to actually do. we just need like a proper angle. So for chalk I already did one, and I think I went with 15 degrees. So what I did, I just pull it up. Let's see, I think it should be okay right now to okay, let's do it like this. So let's do maybe 1.2 over here and 1.2. And if we go back to the keyboard shape, it's gonna be something like this. And we add the bottom plate, for example. And over here we have what? We have a pointing device. Okay, let's add it as well. Yeah, so this is how it's gonna look like from the bottom. I'm no longer in 360 for 3D and easy day for PCBs. Okay, maybe you should give it a try with Design Spark, because with Fusion you have some limitations. I mean, with Design Spark you also have some, but maybe like with Design Spark you can still make money on your design, even if it's a free version. But what you don't have export to DXF. So that might be difficult if you're doing PCB. I don't know if 360 have that. Probably it does. And there's no mirror feature, but it's not really needed. Okay, so in reality we're gonna have two different tenting solutions. So one will be for MX. Let's change that. MX, and the other one will be for chalk. Or maybe let's go with chalk first, because I have this already prepared in a way. Okay, so how are we gonna do it? I think it would be better if I just copy this stuff. I can put it together as one piece. Okay, let's do it like, I don't know, maybe 25. And what we can do, I can drop a line over here. I'm gonna move it by, let's do maybe 1.2, it's gonna be enough. Because we need a little bit of thickness even on the outer side. Now I can do it like this, attach over here and do 15 degrees. That looks a little bit excessive. Okay, I think I have one design somewhere hidden in the depths of my old prototypes. Maybe not this one, maybe number 5, or maybe number 3, because I did tenting somewhere else. Like on the old one. Ah yeah, correct. So what is the angle over here? I hope I'll be able to measure like this. Okay, not quite. Is it 4 degrees only? It looks more like 6. Angle 84 over here. Okay, so it's 6 degrees because it's like 84 and there should be 90. Okay, so I think I went out a bit too far. Okay, let's do 6. Yeah, so I can leave this one. So I will use it to clip every other one at the same level. It makes me wonder if I left, what was the distance over here? 1.6. I think I did 2.4 then. Okay, I hope I can still move it. Although maybe not so much. Okay, how can I measure that? Okay, I think it was 1.2 indeed. Okay, let's chop it off. Yeah, 1.88, so it's okay. Yes, I started with EasyEDA. It's very nice. I can recommend if you're starting out because you have a lot of different footprints already done. And if there is something missing from the manufacturer, there is quite a lot of them that were done by the community. So you can find like a chalk, hot swap, MX hot swap, different stuff. So yeah, it's very good. You will be definitely faster with it. You can finish a project faster. But then, it's stuck on the EasyEDA server. And if you have KiCad, you have your project on your drive. It takes a little bit more time because if you're missing some footprints that you have to do yourself, and then you have to sacrifice some extra time to make it done, but then you have it and you can use it or reuse it. You can share with others as well. I think I have a KiCad somewhere, but I think I have only one. I think I have only one footprint for my encoder, if I remember correctly. Yeah, so on my repo you have only this one, which is encoder that I am using. Oh, wait, there should be more. Oh, there are 3 repositories, right? Okay, there is KiCad over here. And what do I have over there? Oh yeah, so it's only encoder so far. I was supposed to move all of my stuff from EasyDI because I have quite a lot of different footprints, but okay, as usual, a little bit too lazy to do that. For Fusion I have no tips because I have never used it. Okay, so this one is the one that I was talking about that will be difficult to do because the issue here is that the trackball is a little bit too tall. Like over here. So the ball is a little bit too high. It's not comfortable to work for too long. So what I was planning to do, I was planning to change this part, make this one lower and pull everything down. But then we will have to remember about this connector over here. Okay, so maybe let's start without this bottom plate. Okay, if I can, I wonder if I can cut it like this. Okay. Okay, so I can move it up and down. Okay, how, let's say like 1 cm, can we do 1 cm? Most probably not. Oh, okay, we can do 1 cm. Okay, so let's do 10 millimeters like this. Okay, that's gonna be Okay, let's take a look at the trackball. Okay, so that's the top. Okay, I'm gonna move it to here just for now. Okay, if I have it like this, well, this will kind of defeat the purpose, right? If we have to have a different solution for... sadly, there is no other way to make it like lower. We would have to move this one. So this is like the connecting part, and it's gonna be very high. So that will be the bottom. Okay, how much lower did we get compared to the normal one? Okay, that's quite a lot. That should be perfect. Okay, but the issue now is over here, like we're gonna have to route the wires over here and or maybe over here. So we can't change this part. We can only do something about this one. So okay, then basically we can move it to here. Maybe we can align this part, like so. and lift this one a little bit. Okay, a little bit too high maybe. Okay, like this. Okay, you're back already? That was fast. Okay, because I had to lift it up by 0.4 because I left 0.4 because this one prints with an overhang and I had to accommodate for that. I don't have much confidence in this particular design. So we have one wall over here, one more over here, but there will be still some, we will still have some wires exposed. Oh no, maybe not. Maybe this will close the whole thing over here like this. Okay, maybe it's not that bad. Well, I guess tomorrow I'll have to try to print it and see if it makes sense, because okay, now I'm kind of happy with it. Because it's like way lower. And I like it that it's aligned with this, so there will be like a major difference. And also at the same time, okay, it might not be needed for MX. Yeah, I will have to try with MX as well. Okay, we do have some wires exposed over here. Okay, that doesn't look good. Okay, how about, okay, I can't do it. We have to close it somehow. I don't like it that it's exposed because there will be wires coming through here. And the same goes here. If I make a rectangle over here and I pull it down to this side, that should do the trick. Okay, it's not exposed anymore. Okay, there's a hole over here. Okay, so I think I can do the same over here. Let's go and do rectangle from this that are sticking out. Okay, 1 second. Okay, yeah, so maybe it's not that bad. A little bit too much plastic to my liking. Let's make it smaller, like 1.2. We don't really need this wall to be this thick. And also this will be easier to carry the wires. Okay, maybe it's the not nicest design, but I think it should do. Okay, I think we can finish on this one because that was the most important part that I wanted to tackle. I think the rest, because the rest is not difficult, all I have to do for the rest would be just to extrude the bottom parts, which I already have done. That one was like the part that was kind of getting in the way because trackball is way too high over here. So now I have these parts printed out. I will just print this. I will try it tomorrow, and on Wednesday I think we're gonna finally start with the trackpad, not the trackpad, with the micropad that I wanted to do. Yeah, I haven't decided yet if I want to have 8 keys or 12. Yeah, so maybe I will drop like a questionnaire, something like that on YouTube. I don't know if it even works. We'll see. Okay, I think it's ready to print. I'm gonna print it off stream, and the rest I will also finish off stream. I think the project is kind of closed, I guess. I think we can... I will still look into it for a couple of days, and maybe... Let's see, maybe over the weekend, maybe next week, we will do a live build of this little fella. I hope this time around everything will be fine. It won't be needing any kind of changes, extensions, nothing like that. We've put so much thought into it, like make it as flexible as possible. Oh yeah, it should be perfect this time around. Alright, thank you very much for watching. Come back on Wednesday. I will update you on this part if it worked or not. I hope you won't have to work on it anymore. And yeah, I think it's high time to start something else. And that's it. Have plenty of rest today. I see you all on Wednesday. Thanks for watching, and bye bye.